Ladies and gentlemen, I would like to welcome you on our flight CTF Airways 1337 to Beijing. We are happy to have you on board. Please sit back, relax, and enjoy the flight. You and your teammates are on board the CTF 1337 flight to Beijing. Just after takeoff, the pilot and co-pilot accidentally locked themselves out of the cockpit while having a snack. The cockpit door can only be unlocked with a code, and the pilots forgot it. Do we have any hackers on board? You and your team jumped at the opportunity to be the hero. The cockpit door code is not backed up anywhere. A technician from Airbus that happened to be on the plane shares with you a simulator and documentation of the plane network and cockpit door locking system. The flight attendant gives you an Ethernet cable that, according to the technician, leads to a satellite internet router. They ask for your help to get the pilots back inside the cockpit before the plane runs out of fuel. As you can see in this illustration, the MCS 7200, the SATCOM router for this plane, is connected to both the private and closed domain. The private domain includes the crew network, which is why the flight attendant found the Ethernet cable that leads to the MCS 7200. Other than that cable, nothing else is accessible from the cabin to the closed domain. The closed domain includes all of the airplane avionics systems. They are connected through something called AFDX. But only some devices in the closed domain have internet access, such as the black box. The black box uses the internet to back up the flight data. The Ethernet cable gave us access to the SATCOM router. It seemed to allow to configure the DNS servers. When setting my IP as a DNS server, I started receiving requests from the black box to the FDR data backup server. Every time you press some buttons in the cockpit door, they get sent in the traffic as CAN messages. This is good progress. The keypad doesn't control the lock. It only sends the buttons pressed to the CDLS. But unfortunately, the connection between the keypad and the CDLS is throttled to one combination every 2 seconds. The CDLS circuit contains two independent logic components that check the combination is correct. One checks the XOR sum of the keys as a bitmap, and the other the OR sum of the keys valued XORed with the key. These sums are sent back to the keypad for debugging in the lights. The first system exposes the XOR sum of the used keys on the lights. Pressing a key switches the state, so pressing an even number of times is the same as not pressing it at all. The second system is a simple OR sum over the XOR of each key, but it doesn't check the complete password. It stops when the user presses enter, so it's possible to finish early. The OR sum is public. It's displayed with the lights. The CDLS only unlocks if both systems agree and the lights of the keypad illuminate based on the return value of the CDLS. However, the second system output is only visible if the first system returns 0. That's clearly broken. It's probably a backdoor. The bitmap XOR sum can easily be used to extract the characters in the key. Also, the OR sum can easily be used to brute force the key bit by bit. Doing both at the same time is a lot harder, and it could take many days to find the combination because typing the combination on the keyboard is so slow. After doing the calculations, your team and the technician agree that solving this problem before the plane runs out of fuel is impossible. Hey, it seems there's a command injection bug on the MCDU's telnet interface. Such a shame it's on the AFDX network we can't access. Can we maybe use protocol smuggling to exploit it? We have an HTTP request from the black box after all. Maybe a 302 redirect. The black box can access the MCDU even if we can't. This could allow us to make the attack at full speed as if it sends the key presses directly to the CAN bus and bypass the throttling. But we would need to do the attack blind and just hope it works. Your teammate codes the exploit against the circuit, and then you use the protocol smuggling attack to upload it to the MCDU. After 10 minutes of suspense, your server receives the combination and the cockpit door opens, allowing the pilots to go back in and continue to fly the plane. You and your teammates close your laptops and take a well-deserved nap. Ladies and gentlemen, we have arrived in Beijing. Please stay seated until the seatbelt sign is off. We would like to thank you for flying with CTF Airways and hope to see you again on board one of our flights soon.